All right, so we've talked about all the competition between substitution and elimination, but there's one little nugget that we haven't talked about in this chapter. That's amines. Amines are good bases. They're weak bases, but they're good bases. They're also good nucleophiles, and they're important in a lot of other things. Here are a lot of structures that have amines in them. There are some amines, oh, that's an amide, sorry. Amine, yeah. There are a lot of amines in natural products, in biologically active compounds, and a lot of these are drugs and things. Amines are important. So, the problem is, if you try to prepare an amine by substitution via SN2, you get problems. Let's talk about the problems. According to these curved arrows, what I would get is NH3 connected to an R group. Well, NH3 is ammonia. Ammonia is a base. So if I have some NH3 around, after I do that substitution, that NH3 is going to deprotonate that ammonium ion to make an NH2R compound. That NH2R is a primary amine. Look, a primary amine. If that primary amine undergoes another SN2 reaction, we get, my handwriting is too big for this. We get this guy with 2 R groups added and a positive charge. But imagine there's still some ammonia left over, or some of the primary amine left over. Amines are bases, so after you make that ammonium can be cleaned up to make this thing. This is a secondary amine. Look, secondary amines can act as nucleophiles and do substitutions as well. That secondary amine can become this and have 3 R groups connected with a positive because it's got 1 H left. And some of your amine, a primary amine, a secondary amine, and ammonia, something that's left over in solution, can act as a base to deprotonate that thing and make you this NR3. This is a tertiary amine. And look, even tertiary amines can undergo SN2 substitution to get you here. And here is the stopping point. This is a quaternary ammonium salt. It's a quaternary ammonium salt. You can't lose a hydrogen to make it neutral again. It's stuck as a quaternary ammonium thing. So what's the point of all this? Amines, ammonia and other amines, are good nucleophiles. They can do SN2 very easily. In fact, they do it so easily that then they're a base to become a substituted amine that can then do another SN2 and then act as a base to make a secondary amine, a substituted amine, that can then act as another nucleophile. Yet the problem is that they're so good at being nucleophiles and bases that they don't make, if you were trying to make a primary amine as your only product, they don't stop there. That's not good enough. If you put together these 2 things in solution and you wanted that orange boxed thing as your product, that's not what you get. You get a mixture of primary amines, secondary amines, tertiary amines, and even quaternary ammoniums. Primary, secondary, tertiary all have similar reactivity, so you get a mixture of primary amines, secondary amines, tertiary amines, and quaternary ammoniums. Yes, this says only a little bit of tertiary amine, only a little bit of quaternary ammoniums. Yeah. If you are trying to, if your goal is to synthesize a primary amine and only a primary amine, you need to undergo a different type of synthesis. A simple SN2 reaction won't work because amines are too good at being nucleophiles and too good at being bases. That's the point. Let's say we're trying to synthesize a primary amine. This kind of method, not the best way. Here is one way that you can synthesize a primary amine. Primary amines, yeah. React an alkyl halide with an azide ion, that's an N3 minus. What that does is an SN2. Here's a primary alkyl halide. Primary alkyl halide says SN2. So N3, that's sodium azide. The Lewis structure for azide is weird, but this is it. N3, SN2. We're going to do a substitution. I got a little bit crowded, but I'm attacking that carbon. I'm kicking out my Br. I get, oh, that's behind there. I get this product. This product not going to undergo multiple substitutions because it's not an amine. It's an azide product. That azide product, not nucleophilic, not going to attack again and again and again. Look at this explosive. Once I have this azide compound, I can reduce that azide in order to get a primary amine out of it. The reduction conditions are such. We're not going to talk about the mechanism of how this lithium aluminum hydride, LiAlH4, lithium aluminum hydride, we're not going to talk about the mechanism of how that happens right now. We're going to talk about it next semester. But lithium aluminum hydride gets rid of 2 nitrogens and replaces and puts 2 hydrogens in their place. We end up with a primary amine. Okay. I said there are 2 solutions for making a primary amine. That's one way. The second way is to react an alkyl halide with a cyanide ion. We have a secondary alkyl halide. Anions? Yes. Strong base? No. We've actually already talked about why cyanide is not a strong base. No. Therefore, SN2. So cyanide undergoes SN2 with this thing. Uh-oh. I should have pointed this out. This has a secondary alkyl halide up here and a secondary alkyl halide down there. This secondary alkyl halide is aryl, A-R-Y-L, aryl. This secondary alkyl halide is benzylic. Aryl does not do substitution or elimination. Let's not go there. This guy will do SN2. So I just drew it without really pointing out why, and I should not have done that. I get this product with a little cyanide. Iodide still over there. A little cyanide connected. That cyanide can undergo a reduction reaction to give a primary amine. Look, the reagents are exactly the same as above. It undergoes a reduction reaction to give the primary amine. So let's draw that primary amine product. The last one got rid of 2 nitrogens and put on 2 hydrogens. This one does not get rid of the carbon. It only adds hydrogens to the carbon and hydrogens to the nitrogen and gets rid of the pi bonds. How the reduction happens, something we will cover later next semester. But this reduction makes me a primary amine. 2 different ways to make primary amines. Why are they so much trouble? Because if you try the typical SN2 with an amine, it's going to not do once, twice, or even 3 times. It will react to make quaternary ammonium salts, and you get a big mixture of products. These 2 methods give you only the primary amine as a product. Okay, I'm really done. That's all.